Hello everyone, I'm Professor Wolverine, and today I'm going to be teaching you about integration by parts. What it is, when to use it, and what it's good for.
What it is good for? Absolutely nothing.
You're a f***ing idiot. Don't listen to that guy. Okay, so what is integration by parts? Do you remember product rule from Calculus 1, first semester calculus? Well, integration by parts is essentially the integration analog of product rule. Okay, so first let's recall product rule.
What is it good for? Absolutely nothing.
The product rule says that for two functions, u and v, that the derivative of the product of u and v is equal to the derivative of u times v plus u times the derivative of v. Right? So now let's rearrange this. So we can rearrange this as so. So this implies, so this is the implication symbol, that u v prime minus u prime v is equal to u v prime. Okay, so all I did was I subtracted this term from both sides. So I basically moved this over to the left-hand side. But you should think of it as subtracting. So now we have this thing here, right? So let's integrate it, or anti-differentiate it, however you want to view it there. Basically the same thing, right? So integrate both sides. So what's the integral of uv prime? It's just uv plus a constant, right? So the integral of the left-hand side is, so again, implication. The integral of the left-hand side is just uv minus the integral of u prime times v, right? Now, what's the integral of, well, the right-hand side, the bottom? It's just the integral of u times v prime. Okay? And this right here is integration by parts. So this is what it is. So this is the formula, and it's derived by product rule. Okay, so now when should we use integration by parts? Well, when you use product rule. You use product rule when you have a product of functions and you want to compute its derivative. So when do you use integration by parts? Well, you do it when you have a function which you recognize as a product of two other functions, one of which you could easily differentiate, one of which you could easily integrate, right? Because that's what we need to do for integration by parts. Basically, suppose you want to integrate u v prime. So to do so, we're going to have to integrate v. I meant you're going to have to integrate v prime. And we're going to have to differentiate u. But as long as we know how to do that, then we could attempt to use integration by parts to compute this integral right here. Okay, so this integral. So let's do an example. Okay. If you're confused now, an example should help clear it up. So, all right.
Alright, man. Living.
Alright. Okay. Pay attention right now. This is important. So suppose you want to compute the integral of x times e to the x dx. How do we do it? Now let's recall integration by parts. What do you think about that? Okay, so integration by parts says that the integral of u of x times v prime of x is equal to what? What is it? Tell me. Yeah, you got it. Is equal to u to the x times v to the x minus u prime, the integral of u prime of x times v to the x dx. Okay? So now I want to take this integral, this quantity, this is what we want to compute, and match it up with this, so then we can use integration by parts. So look, so this looks like this. This thing right here looks like this thing right here if we let u to the x equal x and v to the x, or v prime to the x, e to the x, right? So now to use integration of parts, we need to first, well, two things. We need to compute the integral of v prime, right? So v prime is e to the x, so what's v of x? Yeah, so v of x is just e to the x, right? The derivative of e to the x is e to the x, hence the integral of e to the x is e to the x. Got it? Alright. Okay. Now, the second thing we need to do is compute u prime, right? So u of x is x, so u prime of x is just 1. Okay, so now we can use integration of parts. So now we have that, so I'm going to label this smiley face. Okay, so smiley face is equal to this. So then smiley face, via integration by parts, what do we do? So we take u times it by v, so we get x times e to the x, and then we subtract off okay, we subtract off u prime times v, the integral of u prime times v. So that's just, so u prime is just 1. So we get, well, 1 times e to the x dx. Okay, so 1 times e to the x is just e to the x, right? So this is the same as just the integral of e to the x. The integral of e to the x is just e to the x. So this is equal to x times e to the x minus the integral of e to the x, which is equal to x times e to the x minus e to the x plus a constant. Okay? I wasn't keeping track of the constants before, but at the end of it, you need to have a constant there. So it's equal to. And if we want, we can simplify this. We can write it as e to the x times x minus 1 plus a constant. All right? So that's what it is. Okay, so maybe we should check that it's right. Let's check that it's right. Okay, let's do it. How would you do it, actually?
No, God! No, God, please, no! 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 No!
Okay, so in order to check that we have the right answer, all you have to do is take the function that we got, that we think is the integral, differentiate it, and check that you actually get x times e to the x. Okay? And then I'll just wait. Just pause the video, do it, and then I'll do it with you. Pause. Pause.
Just do it! Yes, you can!
Welcome back. Did you get it? Okay, so let's check together. So to check if we got the right answer, all we have to do is differentiate this and see if we get x times e to the x, right? So let's take x times e to the x minus e to the x plus a constant. Okay, so I'm going to erase this. So now let's differentiate this, okay? So to differentiate this, we just use product rule, right? So the derivative of this via product rule is e to the x plus x times e to the x. And now the derivative of this, of e to the x, is just e to the x. So we get minus e to the x. And then we have this constant, this differentiates to 0. So the derivative of this thing is this thing. Now this cancels with this. So this is equal to x times e to the x. And voila! So when we differentiate this function, we got this function, hence the integral of this function is this function. Ta-da! Okay, so if you have any questions, I'll be available in the comments and I'll be responding. Otherwise, please like, subscribe, share, and of course, comment, hit the notification bell, and I'll be uploading more videos. If you have any questions or suggestions for videos that I should make, let me know. And for now, Professor Wolverine, see you next time.